Okay, it looks like a tough one, and by that I mean that it's going to take some time thinking through it. The first thing I would encourage you to do is just kind of look at the cosine curve, and the cosine curve looks like this over here. And I got to do the integer multiples of pi now. So at 2, you get plus 1. At 3, you get minus 1. And I hope you start to convince yourself back over here, it's going to be plus 1 again. So this alternates. And I'm going to write this a little better fashion. N equals 2 to infinity. And that would be minus 1. Well, it's going to be n, because n starts at 2, by the way. And then you get the natural log of 4n. So my issue over here is that this isn't so bad to write down. And I know what an is. I'll write this down for you. An is going to be 1 over the natural log to the 4th power n. And what do I know about this? Certainly, it's going to do nicely with the AST. I know an plus 1 is less than or equal to an. And again, this is for n greater than or equal to 2. And I know the second thing, the limit as n goes to infinity of an is equal to 0. So at minimum, I know it's conditionally convergent. At minimum, I know that. My problem is the absolute convergence part of it. So what I'm going to look at the absolute value of it, and what do I got? I got something that's really tough to compare, and I'm going to do the absolute value of it now. So I'm going to see if it's absolutely convergent, ln4 over n, and I've got suspicions. I'm not quite clear, how foundational they are, but I got, the belief that this is going to work out for me, right? For some n, by the way. And what I want to do is I want to just rewrite it a little bit differently. And I'm looking at the absolute value of it now. I know this is, oops, sorry about that. I know this is, if I look at the series over here, this is the divergent P series, or harmonic. It's divergent, I know that much. And if this is bigger, right, if I can show it's bigger for some n, by the way, I got to find some n where it's going to be bigger forever. So it could be, 7, could be 9, I don't know. I'm going to figure that out. And this comes the tough part. I'm going to rewrite it a little bit differently. I'm going to write this as n greater than the natural log 4th power n. So what I would recommend doing is, and I do recommend it, I recommend using technology. And what I do over here is I'm gonna graph out two things. I'm gonna graph out y equals x. That's this thing over here, by the way. And I'm gonna graph this out over here, and that would be y. Whoops. That would be y equals the natural log, the 4th power of x. And I'm gonna, try to figure that out by looking at it. And the problem with looking at things, you might be deceived by looking at certain pictures. So I want to go through that with you. I'm going to look at this picture first, and that's figure 65. All right, I see this over here. I want to put what I'm looking at. I see the line, y equals x, and I see this blue curve, and the blue curve is y equals the natural log. Now, by the way, I realize the blue curve's below it, blue curve's above it, blah, blah, blah. I see that. But, is this going to, I have no idea what's going to happen further out. So what I do is I kind of zoomed out. And I want to go that figure now. I want to go to figure 66. All right? Now, by the way, when you do this, when you zoom out, you might lose detail. But I want to go to figure 66. And this is figure 66 over here. Now, someone says, what happened over here? I lost the detail. But what happened over here, I know there's something going on over here. Now, what do I know? I know this over here is y equals x, and this guy over here is y equals ln to the 4th power x, right? I know the x is above it now, all right? Now, if you keep going out and out and out, I want to put, I went out a little bit further. I kind of zoomed in this region over here to find a point of intersection. And what is it between? It's between these two numbers over here. So I'm going to say, the belief is of this over here, that at some place, that red curve is going to be above the blue curve. All right, let's put this so that y equals x is going to be greater than y equals ln 4th x. All right, I want to go back over here, though. You might need help with this using tools. And I wanted to just go over what we just showed. we show that this is true for some n greater than or equal to, let me go back over that. I kind of can't remember the number. I'm going to say that number over there, all right? We want an integer. Yeah, I'm not going to give a decimal, I'm going to give an integer, 5,504, right? You see that? Back up here. All right, so what did I see in my picture? I saw really 3 points of intersection, all right? I want to go through how to do that using a computer. And using a computer, and this is Sage over here, you know, 0.4, that's this number over here, by the way. This number over here is, you know, 4 point something, that's over there. And then this number over here was that 5,503 point something, and that's this number over here, and that's the zoomed in portion of it, all right? So I'm gonna say over here, pretty conclusive now, that if I pick an n, you know what, I think I made a mistake there. We'll have to correct it. N greater or equal to 5,504, and I'll make the correction, so I'll write down correct. All right, so it's conditional, all right? What I basically showed, that at some point the natural log function just overpowers it, right? And this is divergent, so that what's above it is also divergent. So the answer here is it's conditionally convergent, and that's a tough one, all right? Thank you.